In this video, we're going to take a look at solving absolute value equations. So absolute value, as a basic definition, is the distance of a number from 0. So if we think about the number 5, 5 has a distance of 5 units from 0 if we look at it on a number line. So we would say the absolute value of 5 is simply 5. Negative 5 also has a distance of 5 on the number line, so we would say that negative 5 would also have an absolute value of positive 5, because again, it's a distance from 0. So you want to keep that in mind when we're solving equations soon. So let's look at a couple of more simple examples. So think about negative 3. The absolute value of negative 3. That would have a distance, so here's negative 3, of 3 units away from 0 on our number line. So the absolute value of negative 3 is positive 3. 12 would have a distance of 12 from the number line. 0 has no distance, so that's just equal to 0. And then the absolute value of negative 4, but then it has a little negative 4 in the front for this next example. That would give us a negative, and then the absolute value of negative 4 is positive 4. So total altogether, that would still be a negative 4 because of that extra negative out front. In the next example, we have the absolute value of x equals 7. So you want to think about what number would have a distance of 7 from 0. So if we think about 7 units away from 0, that would give us 7 or negative 7. So we would just simply say x could be 7 or negative 7. Or actually a better word is both. So let's put and. It's both. So then the next example has the absolute value of x equals negative 9. So think about what number x could have a distance of negative 9 units from 0. So no number has a negative distance away from 0. So we would just say this is not possible. And there is no solution for this. Or like the little symbol for no solution would also be okay. Alright, so we're going to move on to solving a few absolute value equations. The following 4 steps you want to write down. The first step is to isolate the absolute value expression if it's not already isolated. Number 2, set what is inside the absolute value symbols equal to a positive and a negative quantity on the other side of the equal sign. Step 3 is to solve for your variable, and step 4 is to check your solution. Alright, so example number 1 already has the absolute value symbol isolated. There's nothing outside of the absolute value of n minus 4. So we can move on to step 2 and set this equal to 13 and n minus 4 equals negative 13 and solve. So to solve, we would add 4 to both sides, so we get n equals 17, and then n, if we add 4, let me write that step down so you can see it. So let's add 4 to both sides, so n would equal negative 9. But then we have to check our work, so I'm just going to use a different color to plug it back in. You always want to plug it back into the original problem. So the absolute value of 17 minus 4 is equal to 13, and you're checking to see that that is true. So that gives us the absolute value of 13 is equal to 13, and yes, that is indeed true. Then let's plug negative 9 back into the original equation. So the absolute value of negative 9, we already checked 17, minus 4 is equal to 13. So that gives us the absolute value of negative 13 equals 13, which is true. Alright, so let's solve number 2. Number 1 had 2 solutions. So the absolute value of 5x minus 4 equals negative 6. Think about what is in here represents a distance from 0. Is there a distance from 0 that would equal negative 6? No. So this is not possible. We can stop right there and say that this would have no solution And if you did solve this, you didn't notice in the beginning it was equal to a negative, you would end up with two solutions, and when you check them, they would not work. So you would do a lot of extra work that you don't have to do if you recognize that right away. All right, we just have two more examples. All right, I've already got the right color pen. So 7 times the absolute value of x plus 3 equals 42. We need to isolate the absolute value symbol. So let's divide by 7 to get rid of the 7 out front. So we end up with the absolute value of x plus 3 equals 6. And then we can set up our two equations. So one kind of looks like what you're given, just without absolute value symbols. And the other one is equal to a negative 6. You only change the sign of the 6. Notice I did not change the other side. And then I'm going to solve. So let's subtract 3 to solve for x. So x would equal 3, possibly. And then let's subtract 3 on this side. And we get x equals negative 9. But as I mentioned, we got to check our solution. So you always want to plug it back into the original problem. So 7 times the absolute value of 3 plus 3 equals 42. We're checking to see if that is true. So 7 times the absolute value of 6 equals 42 is indeed true, because that is 42 equals 42, and that does check out. So x equals 3. Then let's check negative 9. So 7 times the absolute value of negative 9 plus 3 equals 42 will give us 7 times the absolute value of negative 6 equals 42, which is 7 times 6, because the absolute value of negative 6 is positive 6. So that also is true. So this equation has two solutions. Let's do one more equation. So let's see, we have 4w the absolute value of 4w minus 1 equals 5w plus 47. So the absolute value symbol is by itself. So we'll solve one equation that kind of looks like what we're given. Our second equation, we need to change the signs of what is on the right side. So make it a negative 5w and a negative 37. So we have 4w and 5w. I'm going to move the 4w to keep it positive. So I get negative 1 equals w plus 37. And then if I subtract 37, I get negative 38 is a possible value for w. And then let's solve this second equation right here. So if I decide to keep them positive, let's add 5w to both sides. So we get 9w minus 1 equals negative 37. So let's add 1 to both sides, and we get 9w equals negative 36, and divide by 9. So w might equal negative 4. We just need to check it. Okay, so let's plug these back in. Let's see. I'm going to erase number 3 to give me some space over here, or at least part of number 3. Okay, so if I check my solution, remember we got to go back to the original problem, and I'm going to plug in negative 38 for w. So I have 4 times negative 38 minus 1, and I have the absolute value of that equals 5 times negative 38 plus 37. So 4 times negative 38 is negative 152 minus 1 equals, and then 5 times negative 38 is negative 190 on the other side, plus 37. So then I get the absolute value of negative 153 equals negative 153. But that would give me 153 for the absolute value, and then negative 153 is still on the right. And that is not true. So w would not equal negative 38. And then let's check this last value, the negative 4. So again, plug it into your original problem. So I have the absolute value of 4 times negative 4 minus 1 equals 5 times negative 4 plus 37. So I end up with the absolute value of negative 16 minus 1 equals the absolute value of negative 20 plus 37. So that gives me the absolute value of negative 17 equals 17. And that is a true statement. So I have one solution for number 4. All right, so that's it for solving absolute value equations.